Hello, this is AP Statistics problem number 6 from the 2013 exam. I'm going to go through the solution of this. At first glance here, I see that we have a time plot, which, I always kind of like to think ahead, like what am I getting into right off the bat. Make sure you read things before you get too deep or think too far. But anyway, we have a time plot, and if we read it, we have tropical storms in the Pacific Ocean with sustained winds that exceed 74 miles per hour are called typhoons. Graph A below displays the number of recorded typhoons in two regions of the Pacific Ocean, the eastern and the western, from the years 1997 to 2010. So this is a frequency of typhoons for the west and the east. Right? Part A, compare the distributions. Right away I'm thinking big three. Sorry, let me move this up. Right away, I'm thinking big three. Whenever you see compare the distributions or describe the distributions, I'm thinking big three. Center, shape, and spread. Center, shape, and spread. Now, don't forget about unusual features, and don't forget about context, using numbers and using the context from the problem. Okay, so compare the distributions of yearly frequencies of typhoons for the two regions from those years. All right, so it's just a straight comparison. So center. I can see that the western, if you kind of follow all this, now they do have one really low here, but most of this is up here. So it has a center right around 31, 32 maybe, right in there. And you can quote that. You can say it's about. You don't have to be exact or anything. I could actually count, like I have 14 different things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if I kind of went up and down and think of it as a kind of a box plot or a histogram or something like that, you could count the center of this. So it goes 7 down and 7 up and find out where the center of this as a median, right? You can find the median. So if I kind of went down, that would be like 1, 2, 3, 4, 5, 6, and then this would be maybe the 7th, right? And then going up, the next one down is this one. So you know your median is somewhere between that point and that point. So it's like 31, 32, just like we were thinking before. So I'd quote the center of this to be 31 maybe, and then on this one I would do the same thing, maybe just count 1, 2, 3, 4, 5, 6, 7, like these are your 7 and 8, so your center is right in there at 19, and you can calculate that. It's just like calculating the median when you have a set of points or a set of numbers. All right, so this is at 31, this is at 19, so I'm going to say the number of typhoons in the Western Pacific, the center of that is about 31, which is higher. You got to use that comparative language. Don't just say this is 31 and this is 19 and leave it at that. You need to compare them. You need to actually say one is bigger, even though it's obvious. Okay, so this is 31, which is larger than the Eastern Pacific center of about 19. Right? You can even say by so many, right? By 11 typhoons. You don't have to say that, but as long as you quote the numbers and you use that comparative language, you're good to go. All right, so that's center. The shape is actually hard. You can say they're trending, but I can see in part B here, you can see they're going to talk about how did they change over time. So I'm going to talk about the trend of this in part B. So the shape of this, I'm going to kind of skip that a little bit. But the spread, we can talk about the spread. So on the Western Pacific typhoons, they have a high of 39 and a low of about, looks like 18, right? So you can talk about the range of that. So it has a much larger range than the Eastern Pacific typhoons. The Eastern Pacific typhoons have a range from 25 to 15, which is a range of 10, which is smaller than the range for the Western Pacific. So you talk about the center, talk about the spread of it, and that's good enough for now because we're going to talk about the trend in part B. All right, let's look at the scoring guide, see what they had to say. It's a 2-pager here. So for part A, Western Pacific Ocean had more typhoons than the Eastern Pacific. Notice they're using more as their comparative language in all but one of these years because the last year was the same, right? The average seems to have been about 31. They used 31 in the Western, and which is higher, comparative language, on average than the 19 for the Eastern Pacific. It saw more variability, comparative language more, and more variability in the Eastern Pacific. For example, the range, okay, for the Western is about 21. and 10 for the Eastern. Okay, so you can see that comparative language, they're using numbers and they're using context. And I guess they also mentioned the unusual feature that they both had the same last value in 2010. That's kind of an unusual feature you want to mention. All right, part B, describe how the yearly frequencies changed over the time period. This is just kind of glancing at it and looking at it. So the Western, I can see they're mostly up here, which seems pretty consistent, kind of down and up and down. But then you can see this starts to drop off, right? So it has a decreasing trend. Where the Eastern Pacific's kind of up, down, and then it just pretty much stays flat. So it's pretty consistent. So just briefly, you just have to say it appears the Western Pacific, the number of typhoons, has a decreasing trend, and the Eastern Pacific number of typhoons has a fairly consistent trend, right? So that's all they're looking for. And if you read on the scoring guide, that's pretty much exactly what they say. They do say there's a slight increase in the trend in the later years for the Eastern Pacific. But that's pretty much it. Okay, let's flip the page over. This is very interesting. This happens a lot, and this happens in the real world a lot because it's useful. When you have graphs like we have, that we have here that are kind of erratic, up and down, all over the place, if you want to really see the trend well, it's nice to have what we call a moving average. So this is talking about a moving average and doing a 4-year moving average. So they're talking about taking the previous 4 years, these previous 4 years, adding them all together, and then averaging those. So what's the average of those 4? And then for the next number, you take the previous 4. You don't use the 22. You do 16, 15, 21, and 19 to make the 17.75 average for 4 years. So they continue that through, just taking the previous 4 years, previous 4 years, previous 4 years. So they did that for the East and the West and have a moving average. Show how to calculate the Show how to calculate the 4-year moving average for the 2010 Western Pacific. So that's right here. I'm taking these 4 values and averaging them. So I'm just adding them up, divide by 4, and you'll get an average of 25.25. Now I'm just saying it, but you do need to write it out, right? You got to show your work. You have to show your understanding. Getting the right answer is not enough. You have to show your work and then show that it equals that and then write it in. Like you should always write your context and show your work, right? Okay, let's take a quick look at the scoring guide for that part. Right, you can see that they did that right here. So they even say the 4-year moving average for 2010 in the Western Pacific, and then they show their work, and then they did their answer down there. Okay, next problem. So now they have the same graph, but they've taken the 4-year average, and they've plotted the 4-year average right on top of the graph we had before. Okay, which is just what they tell you here. Now you got to read things. It does say use your answer in part C to complete the graph. Some people might glaze right over that. So we ended up with 25.25 or something. So that's like right in here somewhere for 2010, right? So I'm going to complete that graph. Okay, so we got that. That's part D. I'm going to go right into part E here. So what information is more apparent from the plots for the 4-year moving averages than from the plots of the yearly frequency of typhoons? So what's better about this new 4-year average than what we had before? Well, when you average things, you don't get quite as much variability because you're always averaging 4 things together. So kind of the middle, down, up, all average to give you this one plot here, right? And then the down, up, kind of average to give you this plot. So the averages kind of flattens it out a little bit, like gives you a better idea of the trend, right? So I can see, so what you want to say for this question is that I can see the trend for both the Western and Eastern Pacific number of typhoons a little better. It's more clear that the trend for the Western Pacific is decreasing and the trend for the Eastern Pacific is consistent and with maybe a slight rise in the later years, right? So that's what they're looking at. And then for the second part, what information is less apparent? Well, when you do this average, what are you losing? Well, you're losing that variability, that year-to-year variability. You're losing that. If I didn't have that original data in there, I wouldn't know like what the up and down was from year to year. So you just say it's more difficult to, or you can't see the year-to-year variability and the overall variability of the number of typhoons for the Western Eastern Pacific. Okay? And that's enough. That's good. Let's see what the scoring guides look like. So there's their plot point that they did for that part. And then they talk about here the overall trends were more apparent, right? So, and they also go in to tell you what they were. So the number in the Western Pacific is decreasing, and there's a slight increase in the Eastern Pacific, right? And then what do you lose? The year-to-year variability in the number of typhoons is less apparent. You can kind of get an idea, but yeah, it's not as apparent. You lose that, right? Okay, thank you very much.